And so we need to go back and refresh our memories about a couple things that hopefully we have talked about in Algebra 1 and geometry. First of all, here is the radical symbol. It's a square root symbol. I might often call it a radical, but I sometimes call it a square root. I use both terms. The radicand is the value under the radical. It's the value under the radical. And to make it a little bit better, so there I tried to put it in words there. The value underneath the radical. And now my radical symbol is not in the right space. I don't know if it was worth it. Radicand comes from the French. The D actually isn't pronounced. It's radicand, not radicand. And I do use that word upon occasion. A number made by squaring a whole number is called a perfect square. And before we even talk about these other two, let's jump down just a little bit here underneath that dark black line on your notes, and let's fill in our perfect squares. And they are squared. 1 squared means 1 times 1, which is 1. 2 squared means 2 times 2, which is 4. 3 squared means 3 times 3, which is 9. 4 squared means 4 times 4, which is 16. 5 squared means 5 times 5, which is 25. 6 squared means 6 times 6, which is 36. 7 squared means 7 times 7, which is 49. 8 squared means 8 times 8, which is 64. 9 squared is 9 times 9, which is 81. 10 squared is 10 times 10, which is 100. 11 squared is 11 times 11, which is 121. And 12 squared is 12 times 12, which is 144. And if you recognize some of those numbers, and I hope you do, it might be because of the quick recalls that we did back earlier here in the school year, because those were parts of it. So let's go back and look at that. A number made by squaring a whole number. Squaring means times itself. We did 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so forth. That's called a perfect square. The principal root of a number is the positive square root of a number. And we typically deal with the positive square root of a number, but we need to keep in mind that the square root of 4, which most people are familiar with, the square root of 4 is 2, and it's not the only value. The square root of 4 is also negative 2. 2 times 2 is 4. Negative 2 times negative 2 also equals positive 4. So it's both of them, but we typically refer to as the principal root, which is the positive. We typically say, well, what's the square root of 4? 2. When we can't simplify a radical, then what it is called is it's called an irrational number. It's a real number that cannot be expressed as a ratio of integers. Well, what that means is that we can't
write that value as a fraction. You may have heard it defined in your younger math days as a non-repeating infinite decimal. When we type it in our calculator, we get this big, long decimal number. That's a non-repeating infinite decimal, a number that cannot be written as a fraction. But again, we did the first 12 perfect squares, and the nice thing is you could see them on your paper, even though I can't see them on here. But what we're going to practice today is how do we simplify a radical? And sometimes we have a perfect square and we can take it completely out from underneath the radical, and sometimes we don't. But that doesn't mean that we can't still simplify. There's two methods that we can use to help us simplify radicals. The first one requires knowing the different perfect squares. So when we look at 72, what we need to know is that 72 is 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, and 8 times 9. And what we're looking for when we do these, or when we're simplifying by using perfect squares, is we need to find the biggest perfect square that's in 72. What's the biggest perfect square in 72? Matthew?
4.
There's a higher one, actually. There's an even higher one.
36.
There we go. 236. So what happens is we could rewrite this as the square root of 2 times the square root of 36. We can't take the square root of 2, but what is the square root of 36? Matthew?
6.
It's 6. So this becomes 6. The square root of 36 is 6. Radical 2. That is not my method of preference. I have no issue with it. But the reason that it's not is, what if you don't find the biggest perfect square? If you don't find the biggest perfect square, then you think you've got the answer right, and you don't. So my other method here is using a factor tree. So in this particular case, all that we need to know is we need to know one set of factors that multiply to be 80. In this case, maybe 8 times 10. And there's nothing wrong with you using 4 times 20, 5 times 16. There's nothing wrong with that. But what we're going to do is 80 is 8 times 10, and 8 is actually 4 times 2, and 4 is 2 times 2. 10 is 2 times 5. There's probably a little bit more writing in this method, but I've had success with it. And again, I don't mind which method you use. So 80 is 2 times 2 times 2 times 2 times 5. 2 times 2 times 2 times 2 times 5. And what has to happen here is we're looking for 2 of the same value to take out 1. Well, we can get there. 2 of the same value, we take out 1. 2 of the same value, we take out that value. With respect to our 5, it's a singular value. We can't take anything out. So we're going to leave it underneath the radical. And finally, 2 times 2 is 4. Radical 5. So you may use whichever method you prefer to simplify. I am going to use the factor tree method. So when we look at this, 63, the first thing that we need to do is we need to find 2 factors that multiply to be 63. 9 times 7 is the first set of factors that come to mind. There's nothing wrong with using 21 times 3. We just have to have two values that multiply to be this. 9 is 3 times 3. And when we're simplifying the square root, what we need is we need two of the same value to take out 1. We have 2 3s. We can take out 1. And we're left with a single 7 underneath the radical. Problem number 2, 50. Same thing. Any two factors you would like to use? 5 times 10 pops into my mind, but maybe 25 times 2 popped into your mind. It doesn't make any difference. 5 times 10. 10 is 5 times 2. So 50 is 5 times 5 times 2. Do we have two of the same value? Yes. Two of the same value, we take out 1. We have a single 2 that's going to stay underneath the radical. Number 3, 81. Does it? It's 9 times 9. And actually, 81 is already a perfect square, but if you do want to make a factor tree, look there. I know 9 breaks down into more, but do you have two of the same to take out 1? Yes. Square root of 81 is 9. And conceivably, you don't even need that. But it depends. Do you know that fact or do you not know that fact? If you look above on your paper, you see the list of perfect squares, and that can give it away. The problem number 4, square root of 19. Well, 81 is a perfect square, but 19, Matthew. There's nothing we can do. So I just wrote, can't simplify. 19 is prime. The only factors of 19 are 1 and 19. We don't have two of the same value to take out 1. So we kind of like those. Those don't take very much time. But then we get to number 5, and people go, oh no, here comes a fraction. Well, the thing about the fraction is, it's the square root of 1, and it's the square root of 9. Break apart fraction. Can we take the square root of 1? And if you look above there, because it's still on our front page here, if you look above at your perfect squares, look at the first one. 1. It's 1 times 1. We have two of the same value. We can take out a 1. We can simplify 1. And if you were one of those people that said no, write it out. Square root of 1 times square root of 1. Square root of 1 is 1. Two of the same. We can take out 1. Can we take the square root of 9? What is it? Good. So again, on problem number 6, we're going to see a fraction. And when we see a fraction, separate it. Make it the square root of 5. Divided by the square root of 24. Can we do anything to the 5? No, we can't do anything to the 5. But we can to the 24. And pick 2 factors. It doesn't matter if you pick 4 times 6. It doesn't matter if you pick 3 times 8. It doesn't matter if you pick 12 times 2. Pick 2 of them. 4 times 6, in that case, 1, 2. 4 is 2 times 2. 6 is 2 times 3. And what we need is we need 2 of the same value to take out 1. So again, we couldn't do anything with the 5. But we have 2 of the same. And then what we're left with here is 2 times 3. We had 2 single values, the 2 and the 3. We're going to multiply those together to get the 6. Now, just as a little aside, technically, we're not allowed to have a radical in the denominator. So I'm not going to spend my time on that today. But technically, we would have to do more work to this problem to simplify it. Right now, we want to focus on simplifying radicals. Because as we look here on the back, well, what if our square root has a coefficient? Well, that's okay. Coefficient is a number out in front of there. When we look at this, we're still going to simplify. And 12 can be broken down into 4 times 3 and 2 times 2 times 3. We need 2 of the same value to take out 1. So we get 2 radical 3. But don't forget, there was a 6 out in front of the radical beforehand. So there's a 6 out there now. This means 6 times the square root of 12. So this is going to be 6 times 2, which is 12 radical 3. Again, on something like problem 32. Problem number 2, it has a fraction in it, but just look and see. Can we simplify anything? Well, we can simplify the 32. It's 8 times 4. If you chose to do 16 times 2, there's nothing wrong with that. 8 is 4 times 2, which is 2 and 2. 4 is 2 times 2. So really what we have for 32 is 2 times 2 times 2 times 2 times 2. And when we're simplifying, we need 2 of the same value to take out 1. 2 of the same value to take out 1. So we've got 2 times 2. We have a single 2. That's going to remain underneath the radical. But when we simplify that, that's 2 times 2, which is 4 radical 2 divided by 4. We had a denominator when we started. Well, can we do anything more to this problem? Jordan? 4 divided by 4. They cancel out. 4 divided by 4 is 1. And we end up with the square root of 2. Number 3. Another fraction. Same process. We need to simplify what we can. We need to simplify that square root of 18. And 18 is 9 times 2, which is 3 times 3. So this gives us 3 times 3 times 2 for the square root of 18. We need two of the same. Take out 1. So we're going to get 3 at the 2. Don't forget that we're dividing by 2. Can we cancel out the 2's? No. One has a square root and one does not. They have to be exactly the same to be able to cancel them out. When we look here at problem number 4, what we're going to simplify, first of all, is the radical part of this, the square root of 28, which is 4 times 7. Again, if you use 2 times 14, there's nothing wrong with that. We just need to pick 2 factors of our radicand. 4 is 2 times 2. And what we need are 2 of the same value. Take out 1. So 28, the square root of 28 becomes 2 radical 7. Don't forget, and I might be speaking more for me than for you, don't forget that we had a negative 5 out there in front. And negative 5 times 2 is negative 10 radical 7. As we approach one more idea here within our radicals here, it says up until now, whenever we see the square root of negative 16, we said that there were no real solutions. And we moved on with our lives. But it turns out we actually can work with that when we have a negative underneath the radical. Well, a new number, I should say that with quotation marks, a new number had to be developed in order to do that. And what we said is, we said that the square root of a negative 1 is going to equal I, and I stands for imaginary. For an imaginary number. We'll talk about I more so when we get farther along in this unit. But the important part here is with the double star. When simplifying a square root, if the radicand is negative, always start with the square root of negative 1 as one of the factors. Always. So when we look at example 3 here, the square root of negative 16, first thing that we want to do, this is the square root of negative 1 times the square root of 16. The square root of negative 1 is off. Do we know what the square root of 16 is? 4. So what we're left with is we're left with I times 4, but really in math, we like to write the number first. It's 4I. Now, it turns out that 16 was a perfect square. But over here with the square root of negative 40, we still need to start off with the fact that the square root of negative 1 is I. Over here, the square root of 40. Pick your factors. Maybe you wanted to use 5 times 8. It doesn't matter. 4 is 2 times 2. 10 is 2 times 5. And we need 2 of the same value to take out 1. So we're going to take out a 2. We still have 2 and a 5. Those are both singles. Those are going to remain underneath the radical. 2 times 5, which is 10. Remember, earlier we had the square root of negative 1. That means it's going to be 2I, radical 10. Square root of negative 1 is off. And I know that you're not very expressive in this class. But the more you say to yourself, the square root of negative 1 equals I, maybe for 2 minutes as you're walking out of class even, that could help you remember it for Monday. Now, I know it says, now try these on your own. I want to look at problems 3, 4, and 6 to finish here. I've already gone over my time limit, so might as well make the best of it. Square root of negative 45. Once again, when we see a negative underneath the radical, it's going to be the square root of negative 1 times the square root of 45. Square root of negative 1 is I. 45. We need to make our factor tree. 9 times 5. You can use 15 times 3 if you prefer. 9 is 3 times 3. And what we need to simplify. 2 of the same value to take out 1. So we're going to have 3 square root of 5. Don't forget the I. 3I square root of 5. I tend to like to write the I where I write it. Sometimes a teacher will write it after the radical. Sometimes I think that gets confusing. Problem number 4. Square root of negative 11. Square root of negative 1 times square root of 11. Well, what's the square root of negative 1? I. Again, the more you can say it, even if you're only saying it in your mind, it's going to help you remember it when you get here next week. Square root of negative 1 is I. Can we break down 11? No, it's fine. Last one, problem number 6. Negative 90. Square root of negative 1 times 90. Square root of negative 1 is I. 90, we need to simplify. I did 9 times 10. There's other factors you could use. 9 is 3 times 3. 10 is 2 times 5. We want 2 of the same to take out 1. So when we have that 2 of the same, we've got a 3. We still have this 2 times 5 underneath the radical. 2 times 5 is 10. Don't forget that we have an I. And even more so, don't forget that originally the problem said 6 times the square root of negative 90. So we need to multiply our answer here times 6. So when we finish on this, 6 times 3 is 18I radical 10.